We introduced three algebraic properties of the logarithm, and none of them we proved. And you should be critical. As young mathematical students, you shouldn't take for granted any of these formulas that somebody tells you. You should try to justify them somehow. Roughly speaking, each one of these logarithmic properties is the manifestation of a law of exponents. Various properties that you know about how to deal with exponents in expressions can be rewritten into logarithmic form, and they look like these three properties that we saw in the previous video. What I'd like us to do is prove one of them, and then maybe I'll let you think about how you might prove the other two. The one we'll prove is the one that talks about the log of a product being the sum of individual logs. So the log of a times b is equal to the log of a plus the log of b. Here a and b are positive numbers. I'd like us to prove that. The first thing I'm going to do to prove that is just going to help me rewrite the expressions in exponential form. I'm going to take the individual logs that we see, natural log of a, and I'm just going to relabel that with the symbol x. I'm going to let x be the log of a. Similarly, I'm going to take the log of b, and I'm just going to relabel that with the symbol y. So y is the log of b. We're going to take each one of these equations now involving a logarithm and rewrite it in exponential form. So remember here, because it's natural log, it's base e. The result that you get out of a logarithm is the exponent, and the thing you're putting into the logarithm is the result. Similarly for the other one, e to the y is equal to b. Now I have good reason, looking at the original expression, to multiply a and b together. Here's a and here's b. Let's do it. A times b. Well, a is e to the x and b is e to the y. Now we are multiplying two powers with the same base, and one of our laws of exponents says that you should add the exponents together. This is what I meant before. Somehow the summation of the exponents here corresponds to the summations of the logs, and we have to make that clear. Right now we have that e to the x plus y is equal to a times b. Well, we're just going to undo what we did when we wrote things in exponential form. We're now going to take this exponential equation here and rewrite it in logarithmic form. The base is e, so it should be natural log. The result is a times b, so that goes into the logarithm. And the exponent, x plus y, should be the result of the log. Take the time to understand this. A times b came out of the exponential function, so it goes into the log. What comes out of the log is the exponent, what goes into the exponential function. But remember, x was just a fancy or a simpler way, really, of writing log of a. So this is log of a. And y was just another way of writing log of b, so plus log of b. And there is the formula we were trying to prove. Can you prove the other two?